Hello, and welcome to the vCenter Operations Overview video. My name is Kit Colbert, and I'm one of the lead engineers on the project. What I want to do for you today was walk you through how to use this product, show you a little bit about the UI, and introduce you to some of the concepts that underlie the product. Now, if you take a look at the screen here, you'll see that this is the main UI that's visible when you first log into vCenter Operations. One of the primary concepts behind VCOps is that we wanted to make it very easy for you to troubleshoot performance problems in your environment. Not only that, we wanted to enable you to identify where the problems are and figure out what you should do first. So you'll notice first off that this UI looks much different than the UI you're used to seeing in the VI client. In the VI client, you'll remember that on the left-hand side there's a navigation tree where your list of VMs and hosts and other objects are. To the right of that is a list of tabs, and those tabs have context for whichever object is selected in the navigation tree. Here we flip it around. Instead of looking for specific objects, what we show you is a high-level view of your environment, representing each object as an icon. Similarly, we color code these objects such that you can tell whether they're doing okay or whether they're having problems. Now, even without knowing much about the UI, and even without understanding the different concepts that we have, just by looking at the colors here, you can get some sort of intuitive idea of how many problems you're having in your data center and where they are. You can see that most objects are green, meaning that they're functioning okay, while a few are orange or yellow or red. So what exactly are the concepts here, and what do these numbers represent? Well, take a look at the upper left-hand side here. You'll see that we have a number of different badges: workload, health, and capacity. So what do these different badges mean? Well, workload, which is what's currently showing, shows how hard an object is working. In the technical terms, it's essentially its demand over its capacity. Demand is how much an object wants, and the capacity is how much it can get. So we know that as demand gets higher and starts approaching capacity, you may run out of capacity and then have a performance problem because of that. So workload allows you to quickly understand how hard your objects are working, your hosts, or your VMs, or even your clusters or data centers, and allows you to take action on that. So what about health? Well, health is a little bit different than workload in that health uses advanced algorithms to figure out how normally your objects are behaving. What health does is takes a look at your objects and their history based on their statistics to figure out what's normal for each stat for your object. It then can trend those stats and figure out whether the current values for them are out of bounds or not. The more out of bounds they are, the more abnormally your objects are performing, and the more likely you are to have some sort of problem. Finally, we have capacity. Now, unlike workload and health, which are more real-time statistics, capacity looks over the longer term and doesn't look at whether you're instantaneously about to run out of capacity, but says, what are you trending towards? How much time do you have left before you completely exhaust your capacity? And as we can see here, most of the objects in this data center actually have a lot of time left. There's a few that are red, and those guys will run out of capacity very soon. So going back to workload, what this view does is again give you a high-level overview of how your data center is performing using three simple metrics, so you can get and understand different aspects of each object. Now, this view is not just for navigation, but it also enables you to do the first level of troubleshooting. Let's say that we find some object that has a high workload. We can select it. The first thing you'll notice is that we get a few more details for it. We see its workload's very high, above 100. Its health is also a little bit degraded, and its capacity is actually perfectly fine. So the workload's high, but the capacity is still fine. So why could that be? Well, what it probably means is that it's a temporary spike, and we can see that this is not normal because health is degraded. if workload was normally high, then health would also be high. So we can compare and contrast these different concepts to get an idea of whether something that's happening is normal. Is it a blip? Is it something that may be one-off? Or is it a long-term chronic issue? And we can understand that just by thinking through the values of these three different metrics. You'll also notice something else happened. When I selected my object, a few other objects were selected and all the other objects were dimmed. These other objects that are highlighted are objects that are related to my object. In particular, this ESX here is running my VM, and that ESX is part of this data center. So I can actually move up to my ESX host, and again, we'll see that I get a workload score for it, and a health score, and a capacity score. Even more interestingly, I can see all the VMs that are running on that ESX host. What has this enabled me to do? Well, I saw that my VM was having a problem, this one here. Now luckily, it doesn't look like my ESX host has a problem, but it may be the case that other VMs on the host are having problems, possibly because this VM is causing those problems. It's unclear. So we see in this case that most of the other VMs are actually green, but a few are orange and other ones red. So more than likely there's not much of a population pressure issue going on here. However, if that were the case, such as this one over here perhaps, or maybe this other ESX host, it would show up very clearly because all the objects there would be red, and you would know then that that ESX host is probably overcommitted and that you need to remove some VMs or lighten the workload within those VMs. So again, this screen is meant not only to be able to show you where your problems are, but also to help you through the first level of triaging that's required to figure out where you should put your attention and then what next step to take. So we see something peculiar here. We notice that this ESX host is red, indicating that it has a high workload, but none of the running VMs on it are red. So none of the VMs are actually having any problem. And we see that there's some other VMs here that aren't running, and those are shown in gray. So why would it be that all of the VMs on that ESX host are fine, but the ESX itself is a bit overloaded? Well, this brings us into the next section of our product. It's the details section. So you notice that when I click on it, I get a few options here. I can go to Details, Scoreboard, or All Metrics. In this case, I want to go to Details to get some more information on what exactly this ESX host is doing. Now, I've navigated into the details for this ESX host. This screen is pretty dense and has a lot of information, so let me walk you through it so you can quickly understand it and understand how you can use it to determine what the problem is or what the next step you should take in investigating the problem is. As you saw on the previous screen, we have the same three badges here. We have workload, health, and capacity. And again, we can see that workload is very high, very much in the red, while health is somewhat degraded. The first thing you'll notice just under this view is a breakdown of workload by the four constituent components, and those are CPU, memory, disk I/O, and network I/O. And again, this allows you to very quickly identify what the problematic resource is. We see that CPU, not much of a problem. Memory, not much of a problem either. Same for network I/O. But disk I/O, that's fairly problematic. We see that it's 140%. So what exactly does that number mean? It means that this ESX host wants 140% of disk I/O of what its actual capacity is. It means it's trying to use more than its capacity. And that obviously can represent a problem. The other thing you'll notice here is that these lines above the bar graphs indicate the normal range for that value. So we see that CPU ranges anywhere from 0, maybe upwards of 30%, while memory is actually in a pretty tight bound, somewhere between 10% and 20%. In addition to the workload breakdown, there's a number of other sections on the screen that inform you to what you should be thinking about, what you should be looking at. The first is the key metrics screen, where our advanced analytics select important metrics that might be relevant to the behavior that you're seeing or the problem that you're seeing with this object. You'll notice in this section that we have a breakdown of the workload values. We see here specifically CPU and memory. Now there's three key concepts that you want to be thinking about when looking at this screen. They are demand, usage, and capacity. Demand is what an object wants, usage is what it gets, and capacity is the most that it can get. So again, these three simple metrics, let's think through them a little bit here. We see in this case that demand is equal to usage. So this ESX host is able to get everything that it wants in terms of CPU. But what would it mean if demand was greater than usage? Well, that would mean that this host wants more than it can actually get. That would probably represent a problem. More than likely, the aggregate amount of CPU demand on this host from the VMs running on it is greater than the amount of resources that are available for those VMs. So that would indicate a problem. Here we actually have demand being much, much less than usage. So what does that tell us? Well, that tells us that we might have a little bit of waste here. That indeed, there's all this extra space in here that we could be using. So in terms of memory, this host is actually very good and can indeed support some more VMs running on it without a problem. Let's continue looking further down. The next section is the related objects. You'll notice two subsections here. First, we have information about this object's parent. In this case, it's a data center. And we can see the parent's workload. We can also see the peers of this object. Are other ESX hosts suffering in the same way that this one is? Again, this may be some indication of a population pressure problem, maybe with a shared data store or something. In this case, we don't see that happening. There's only one other host and it's green. Finally, we also show child objects. And again, this lets you know whether there's an overall problem on the host that's affecting the VMs or whether the host itself is just a little bit overcommitted. As we continue looking down, we then see the events in workload. What this view is meant to do is to try and help you correlate from when events happen to changes in workload. Now you can see here there's a giant spike in workload, and indeed workload stays pretty high after that. But we don't see any events. So maybe this workload spike happened from the VMs running on this host. We can check out parent objects. We can also look at the peer objects, other ESX hosts in this case, and we can check child objects. Just for argument's sake, let's look at child objects. And again, we don't see any events. So that probably means that nothing that a VI admin did caused this issue to happen. It's possible that some of the workloads within the VMs just started acting up, but it's also possible that maybe there's a data store that's contended for in this case, since we are looking at a disk I/O problem. And given that it is potentially a data store, let's move down to the next section, storage and network. I can expand that tab and scroll down and see a few details about what's going on with this host. The first thing we notice is that we have a section both for storage and for networking. On the storage side, we have stats that look at the overall data store activity. So we can see that this data store isn't reading very much, only about 23 IOPS, but it is writing a lot, about 911. The total throughput isn't that high. It's 47 on the read side, 730 on the write side. We are getting some latency, though, in our reads, about 4 milliseconds. And that's possible from this high level of writes that we're seeing. But let's continue iterating. Now this data store actually looks a lot more interesting. We noticed the one before actually had pretty low total numbers. This data store here has extraordinarily high numbers. We're pushing through 36,000 IOPS on the read side, as well as 36,000 IOPS on the write side. And look at the throughput, 23 megabytes for read, about the same for write, and we see a much higher latency. This latency is possibly what's causing the issue here. Now you notice something interesting that's happened here. We see that things were pretty flat for this data store until recently when you see a spike. So we can actually click here to get a bit more detail on what's going on. So again, this gives us a zoomed in view of that spark line that we were just looking at. Now we can see a few things here. The low point's at 0. The high point is clearly marked with the orange dot at about 100,000. That's 100,000 IOPS. So again, this data store is seeing some significant traffic. You'll see a spike every now and then. So more than likely, this data store is the problematic one. It's overloaded. So in order to figure out what our problem is, we'll need to go and take a deeper look at the data store. Let's switch over to the Analysis tab. The Analysis tab shows us information at an aggregate level, looking at your entire data center. And it allows you to customize all these views such that you can break down data in a whole spectrum of different ways. Let's take a look at our storage. Specifically, let's see what VMs are contributing to our storage load. We want to see which VMs have contention or latency when accessing a data store. So what do we see here? This visualization is what is called a Treemap. Treemaps are very good for showing hierarchical data. So we can see here that we have one data store, this FC16 RAID 6. We have another data store over here that's much smaller in size. Another data store that's so small its name can't even be printed, and then many other data stores here, some of which are so tiny they're barely even recognizable. What is the size based on? Well, we can see here from the name the size is based on the amount of I/O usage, the amount of kilobytes per second. So we can see very clearly, just by looking for a moment, that this FC16 RAID 6 is by far the most heavily utilized data store in our data center. And indeed, if we have problems that are coming from this data store, or that are storage related in general, it's very possible that they are coming from this particular data store. So, what do the colors mean? We see some colors are closer to yellow, while others move almost into the blues or bluish greens. The legend down here shows the amount of latency from 0 milliseconds all the way up to about 35, 36 milliseconds. So again, we can see many of these smaller objects, smaller data stores, are using less I/O. They're not pushing through nearly as much, but they're also seeing almost no latency. Whereas this very large data store is getting in a very large amount of traffic, but also seeing a high latency. Now, the other thing we can take a look at is we see that the VM here, there's a specific VM that's driving all this traffic. In fact, one VM has essentially all the throughput on this one data store. So again, this visualization allows you to quickly identify who the largest users are based on any type of metric you want, whether it's storage, network, memory, CPU, health, what have you. You can then break it down either by ESX host, by data store, by VM. So this view gives you an amazing visibility into your data center, allowing you to quickly triage and identify who your heavy users are and where you should be paying attention. Let's navigate back to our ESX view now. Another useful feature of our product is the scoreboard. Now you notice that the scoreboard is somewhat similar to our original overview page. Again, objects are represented as icons. They are colored by how severe their workload, health, or capacity is. In this case, their height is also affected by their workload, health, or capacity score, as well as the size. So this is another useful visualization for understanding which objects you need to focus on. Luckily, in our case here, all our objects are healthy, or are green in terms of workload. Let's check their health. Health actually gives a very different point of view. Whereas with workload, we saw they were all green. With health, a few of them are orange. So what exactly does that mean? Well, it means that in terms of absolute demand over capacity, they're not doing too much, but something about them has changed. So again, we can very quickly see which object is in most need of viewing. So in this case, we want to drill down to get some more details about this VM. But let's take a look at the All Metrics tab just to round out our tour of the vCenter Operations UI. Now the All Metrics tab is really the final level, the deepest level of investigation that you'll need to do. We don't expect that you'll need to come to this tab every time you investigate or troubleshoot a performance problem. Indeed, our hope is that through some of these other visualizations and other information we show on the Details and Scoreboard tab, you'll be able to resolve your issues quickly there. However, in some cases, you need to drill down to the next level of detail, and that's what this view is for. This view shows you all the stats that we collect for a given object, organized by their type. So we see CPU usage stats, not only for the object as a whole, but broken down by each individual CPU. We also show memory, network, so on and so forth. Many of these stats we get directly from ESX. Some of them we derive and create based on that data that we get from ESX. Now, you'll notice that some of these metrics are completely blue, while others have a little bit of yellow in them. What does this yellow indicate? The yellow shows you metrics that are abnormal, the metrics that you should pay attention to. So we see here that our write rate for this data store is abnormal. We can double click and find that we'll get a more detailed view here. And indeed, the section that is abnormal is highlighted. Similarly speaking, we can cross-reference this disk information with CPU information, looking at the abnormal stats there. So this tab is a powerful way to get the deepest level of investigation into what your object is doing and why it is misbehaving. So I think that wraps up this overview video of VCOps Standard, and I look forward to talking with you again in the next video.